Okay, Max, there's a few parts of your question here that I think need to be addressed separately, so color coded. Okay, first off, I'm not sure where you're getting the question from, but it's much more likely with a monopolistic competitor than it is a monopoly competitor. So you might need to go check just where you saw it. The reason it's not very likely with a monopoly is kind of for the reason that you're stating. It's unlikely that they're going to be losing money, that is operating at a loss. There's a few reasons for that. First of all, they are the only supplier, so their goods tend to be relatively inelastic. That's going to matter to our next point as well. Um, and because of that, they're likely to make very high revenue. Therefore, to be operating at a loss, their costs have to be high for some reason as well. It's also unlikely that their costs will be high because if they're a monopoly, they've likely moved their way through the long run average cost curve and are making use of economies of scale and have brought down their average costs. So anyway, I think maybe you misread it wherever you found this, because with a monopolistic competitor, remember, they're much more like perfect competition, and it's very hard for them to make a profit. And they continually have to product differentiate to do so. Important, and this is where I think maybe your error is, you need to understand that monopoly power doesn't mean that they are a monopoly. It simply means that the firm can set the price, unlike in perfect competition, where in perfect competition, the market sets the price, not the firm. So monopolistic competition does have monopoly power. Monopolies have greater amounts of monopoly power, but they both have it. Okay, to the point I made a second ago, remember, it's likely that a monopoly is relatively inelastic. There aren't any competitors, therefore, it gives them a relatively inelastic demand curve. That's important to note because what it means is that the marginal revenue, so this point right here is where where total revenue is maximized, where MR is equal to 0 on both diagrams. Um, the gap from here up is much greater on this diagram on the left because of the steepness of the demand curve, whereas the gap here is much less. So that somewhat indicates a little bit about the price setting power, or at least about how revenue can be affected based on the demand curve. And it's likely that a monopoly will have a much more steep demand curve. Okay, let's see next. Okay, so this kind of follows from this. Your next part of your question, you asked about can they raise price to increase revenue? The answer is always no, because remember, this point where marginal revenue is equal to 0 is also equal, if we go straight up to the demand curve, it's equal to the midpoint of the demand curve where demand is unit elastic. Remember, we said when demand was unit elastic, that's where total revenue is maximized. And this point where marginal revenue is 0 is also where total revenue is maximized. Therefore, they're the same. So if they're profit maximizing, that means MR is equal to MC, and we assume that MC has to be positive. There can't be negative marginal cost. Therefore, if marginal cost is positive and intersects with marginal revenue is then positive, which means it's to the left of this point. Therefore, they're in the elastic portion of the demand curve. Therefore, when they raise price, they're moving away from midpoint. Therefore, total revenue is always decreasing. That was a lot of therefores. Keep in mind that logic does still hold on these two examples. Once they start to move up the demand curve, total revenue diminishes, but there's still this advantage of this massive gap between the two that goes away more quickly in the diagram on the right. Okay, to the third part of your question about profit maximization, I guess we just need to clarify that loss minimization also is a type of profit maximization. And a little joke for you there, of course, because I don't get too many more chances. Okay, and then finally, to make at least a normal profit, I guess my point on this is something I found out more recently. Um, Uber's been in business for 9 years and they still haven't made a profit. And we don't even mean normal profit here. We mean an accounting profit. So they're really losing a lot of money, which is interesting because, from the outside, it seems like a very successful company. So what I think I want to talk about here is coming back to the diagram to draw this with what you stipulated, a monopoly that is making a loss shown by AC being greater than AR. It's actually really hard to draw because if you follow all the rules, average revenue being twice as steep, or I'm sorry, marginal revenue being twice as steep as average revenue, that is, wherever this intersects, this will intersect halfway between them. Remember, which is a mathematical relationship. Marginal cost having to intersect average cost at its lowest point, and then where profit maximization is occurring, having to be a place where what you stipulated is true, it's actually kind of hard to draw. And if we come to this point right here, so the very first marginal cost, assume that this is unit one, it's not to scale here, but assume this is the first unit. And way up here above it is the average cost of making just one unit. Well, I haven't drawn it here, but remember the marginal cost of the first unit is equal to the average variable cost of the first unit. So this gap in between the two represents the amount of fixed costs, and that would have to be rather significant. So again, going back to something I said earlier, that it's likely that QPM is a very big number. And again, let me reiterate that this is not to scale. Because it's a monopoly, this is likely to be a big number. It would be hard to imagine a point where this gap, and that relationship is no longer true because we have more than one unit. But it would be hard to imagine a relationship where the average costs are still that high. Because when you mass produce, remember the fixed costs get spread amongst such a big number that they become irrelevant. But I do think that's what's happened with Uber, is that, whatever amount of fixed costs they have, they're still unable to make a profit because probably, they're operating at a position where the profit they make on each ride or the marginal revenue of each ride is just slightly higher than the marginal cost. Because remember, they pay out to the drivers, that's their marginal cost, that they've been unable to pay off whatever amount of fixed costs they do have. So developing the platform, the servers and the technology to run Uber and all that sort of thing. So it is possible, but clearly Uber they're here, and the reason they're able to keep operating after 9 years of losses is because people believe that their product is good and that it will eventually make a profit. So people keep, subsidizing those losses and investing in Uber so that they continue to run at a cost. So they continue to run even though they're losing money. So I guess to answer your question, how will they continue to make at least a normal profit? Um, they'll continue to work their way down the long run average cost curve. They'll continue to find ways to lower their costs and somehow boost their revenue. And maybe Uber rides become much more expensive in the near future, because maybe Uber is getting closer and closer to a monopoly. They're certainly not there yet because normal taxis, calling a friend, taking the bus, taking the subway in a metro area that has that. Those are all still pretty good substitutes to Uber right now. So you would have to see the demand curve shift to the right, which would take the marginal revenue curve to the right as well, for that to happen.